Okay, we are recording. So first of all, just to mention some basic information of why these tropics are important, of why megadiverse regions in general are important. I would like to, even that we're going to be talking on past ecosystems or past dynamics, I would like to explore the importance that palaeoecology can have in terms of some of the sustainable goals by the United Nations, such as climate action or life on land. So why megadiverse regions are important? First of all, is because on land, forests are the ecosystem that store most of the carbon by far, but not all the forests can store the same amount of carbon. So in this graph in here, you can see that tropical forests accumulate by far the most content above ground biomass in terms of carbon stocks, not only from the point of capturing and storing the carbon, but also tropical regions and megadiverse regions in general. They have geophysical processes such as high evapotranspiration and this recycling of the water that moves, what we call it in the Amazon, the river and aerial rivers, so they can move and transport precipitation from the coastal area, hundreds and even thousands of kilometers inland, and distribute more evenly this water by this recycling mechanism. So it's not that tropical forests are beautiful, which they are, but it's because it's important in a global scale for climate mitigation, climate adaptation, and climate change fighting. But if we talk about megadiverse regions, we need to talk about biodiversity. These megadiverse regions store by far most of the species that live or that have been described so far. Just in Latin America, where I work, we have that 1/3 of the global species richness is hosted in this megadiverse region of Latin America, and half of the recognized countries called megadiverse are in this Latin American continent. This biodiversity is translated into a very high variability of different ecosystems and landscapes. So it's not just multiple species living in somewhere in different places, it's because we have many different habitats and landscapes, and this is traduced in the amount of species. Therefore, the same we talk on natural events like different habitats and different species, we can relate the same diversity into cultural groups. The Amazon, I always make or cite this quote by the archaeologist Stephen Trostate. He once described in a talk that the Amazon for some people is like a huge broccoli, because you see from the earth just this green, impenetrable, massive forest. But the truth is very different. It's not just one large homogeneous huge forest, is like multiple different forests and habitats, also including savannas, wetlands, everything, mountain ranges that lives in this area, that cohabits with different cultural groups that adapt to the different environment. But what is the current state of these megadiverse places? Well, we are not studying or making investigation as fast as the tropical forests are being destroyed. So by far one of the most dangerous threats that nowadays occur in the Amazon in particular is deforestation, that if we couple it with climate change, anthropogenic climate change, is going to have massive consequences that we will surely discuss later on in the talk. But let's start talking about the ancient times, okay? So we have why there is so much uncertainty when we talk about the tropics, and especially when I mention now the tropics, I'm gonna refer from now on to the northern South America and the Amazonia basin, so Neotropical region basically. Well, the first thing is kind of difficult to move around there when you are. So here I mentioned some of the books that I really enjoy. They are not scientific books, but I really recommend you to read in your spare time. And we can see, if you read those books that are talking about different time periods, so we have the expedition of Francisco de Orellana through the Amazon, we have the trips from Alexander von Humboldt, in North and South America, and we have the biogeography of one of the first neotropical palaeoecologists of South America, which is Paul Colombo. We can clearly see in all these three books that they were using the same roads, the same communication system. And that also happened to me when I go there, even if that we talk about 5 centuries after, the main communication or the main communication system are still the rivers, is the fluvial communication, and the roads, although they are much better than Orinoco has found, they are mostly the same one, but improved. So there is a lot of spaces, because there is not a well communicated or developed road system. There are still lots of places where the access is very difficult. Also, for planning a visit, this is a Google Earth image that I took in 2019. And when you are looking for small ponds or lakes, you can infer the difficulty that I have for planning ahead my full work, because we are in a region that is full of clouds covering the potential satellites images. But even inside the place, not with the aerial view, this picture that I really love it. This is in one forest of the Gran Sabana in Venezuela. I was taking the picture of Sandra Nogué, my colleague. I didn't know that Valentin, my PhD supervisor, was that close. They were like 1 meter apart from each other, but the vegetation, although with the flash in here, it looks light and perfectly beautiful. We didn't see that Valentin was that close. So that's kind of the magnitude that you can get to the difficulty to access to different places. Also, as we said, you might encounter different problems, like you have to cross your 4x4 in a very, very weak and unstable bridge, and you have to unload all your equipment. You can have landslide, you can get your car into a ditch, you might have, particular situations you just directly can cross to the place, because the only way to arrive to that place is broken, and you have to forget about it. And this is particularly important in palaeoecological studies, because we use a lot of equipment. So we are not light in weight, and we are carrying a lot of stuff for using different reasons. If you don't have a road system, then you might hope to have some donkeys helping you with your equipment, but normally this is not available, and you ended up being the donkey and transport your equipment towards the places where you have to analyze. But if we start talking about the first written documents that arrived to the European continent, talking about the Neotropics, we are going to be discussing the documents made by mostly militaries or religious people. These documents, we need to rely on one important thing, they are normally very biased, because they were reports to the monarchy, to the crown of Spain mostly, and later on of Portugal. So they are not particularly objective. So we need to, take them with caution. And even if we go to more independent researchers later on in the 19th or 18th century with Alexander von Humboldt, that was during the illustration moment. So all the reports that arrived to Europe were within this idea of the noble savage, where what they call modern civilizations, like in the United States and in Europe, they were degrading everything, and we were so far from the environment. But this nomadic, very low populated, the density with very low population, tribes or cultures, they were living in complete harmony with the environment, where that was not really the case. If we forget about the written documents and we start with proper research, in the Neotropical, in the lowlands of the Neotropical region, first research in terms of past dynamics were archaeology. They started in the beginning of the 20th century. And because one of the main issues that the first archaeologists found is that they were working as we do in other places like Europe. So they were trying to compare the present situation to infer what was the past, forgetting that we have a massive decline in the population after the European invasion into these places. So they were assuming that the lifestyle of the lowlands in the tropics were normally reduced to small groups of people in the inland with very, very basic socio-technology development, and they can be grouped in this hypothesis called environmental determinism, where the societies were very limited because of the environment. The situation was slightly different in coastal areas, but for the main inland, the major or the most important hypothesis was related to these small nomadic groups with barely impacts on the landscape and on the ecosystem that they use, because of this translation to what they could see nowadays. But archaeology continued developing there, and then a bunch of varied and sometimes very big in scale earthworks came up. So we have mounds, we have ditches, we have bricks, we have geoglyphs in here, we have Amazonian dark earths, or terra pretas, how they are called. So the archaeology sphere starts changing from thinking about the pristine wilderness and people, pre-Columbian people living in harmony with the environment, to start thinking that Amazon could be even a manufactured parkland, and all the entire basin was a product of anthropogenic activities. And this is where palaeoecology can help a little bit. One of the best approaches that palaeoecology has is that because we have this continuum in time, we have a trend thanks to the sedimentary record, we can infer dynamics and trends. With archaeology, if you go to an archaeology site and you only have these samples from the archaeological site, then you're going to have like more snapshots of what happened in one particular time. But thanks to palaeoecology, we can make a trend of what was happening in the environment before a culture arrived to a place, during the habitation of the place, and after the abandonment of the place. That's why palaeoecology can greatly help other disciplines such as archaeology, and the other way around. We need archaeology for understanding the human occupation pattern in the Amazon. Okay, so evolution of Neotropical palaeoecology. We've been working in palaeoecology since the late 60s in the Neotropics. But if we compare the Neotropical research that has been carried out so far to other places, we can say even that it's kind of in its infancy. And this is for several reasons. First, palaeoecological works were aimed to unravel the ice age. So mountain regions were prioritized, and especially lake records, because of the regional spatial scale that they provide. As I said, the accessibility is still nowadays a problem, and the nature of paleontological slides, where we didn't have any sort of archaeological information, pollens reference collection, or even basic ecology, made every single step much harder than in other places. If we look to this map here made by Umberto Lombardo and colleagues, these gray dots represent places where paleoecological works have been carried out until 2018, and the pink dots represent places where archaeological works have been carried out so far. If you see, there are two main things that were very shocking for me when the first time I see this picture. First of all, is that we have areas the size of France that are completely unstudied. But another important bit is that if you look at where the paleoecological records are located, they are mostly in the ecotomes and in the boundary locations, whereas archaeological works are mostly being carried out near the fluvial systems, again, because that was, at least today, the main communication system. So it's kind of logical to think that people was going to inhabit it where they can move to somewhere else. So there's a huge lack of overlap. And there is still many things to do to improve our knowledge of how this huge economic basin, as you can see, compared to the continent of Europe, huge basin works and how it functions. So start thinking on the relationship between humans and the environment. Some colleagues we gathered a few years ago, and we tried to make a review or a compilation of the most important works, just to sum up some of the main conclusions of human legacies into the environment. And they were restricted to mostly 4. We took several places that have been well studied, both palaeoecological and archaeologically wise, and the main activities that we could clearly see in the records were the building of earthworks, altering the landscape, modifying the hydrology, also the distribution and dispersal of plants, creation of the Amazonian dark earth soils, and enrichment of plant communities with useful species. These are the things that are more easily to find when we are working on environmental archaeology or palaeoecology. So I would like to illustrate some of the examples where palaeoecology could help archaeology by using a multi-proxy approach. And I would like to illustrate that with 3 study cases in different environments. 2 are from inland and 1 is a coastal environment. So if we start with the Amazonian lowlands per se, we are carrying out work in the National Park of Yasuní in Ecuador. So this particular place, you can see here where it is located in the yellow star. It's, as you can see, South America in general, or the Amazon basin in particular, if you extract the Andes, there is not a huge change in the temperature through time, which is the graph to the left. But if you look at the precipitation regime, you can find differences. So it's easy to think that changes in the vegetation are going to be more related to precipitation change than to temperature change. And here in this location in our study site, you can see that temperature is pretty much the same through the year. But although it rains a lot, and believe me, a lot, you can have some shifts and some changes in the precipitation pattern through the year. So we took this place because of several reasons. First of all, because it has an active geomorphology, so dynamics there are very fast in terms of landscape modifications that are going to affect, of course, the vegetation. It rains a lot, and it doesn't have a marked dry season, but there are some changes, as you've seen in the previous slide. And also it was considered one of the refuge of the glacial vegetation. So we could assume a higher stability in that particular place. Some background also was important to work here because compared to other regions, there was a lot of previous works carried out in this place in terms of palaeoecology that were developed mostly at the end of last century and last millennium. So we have here a summary of the main works carried out in different places in a very small study site. As you see here, the scale is 20 kilometers. And that was particularly funny for me because some of those places that were where the sediment was collected nearby an archaeological site, they found no evidence of human activities. And of the places where they didn't have any clue or any indication or evidence that they might have some people there, they kind of infer some anthropogenic activities, but they didn't establish very clearly what was the proxy that they used for that. So with this in mind, we took a record very close to one of the previous records and analyzed the trends. As we are all paleo people, I'm not going to explain how the pollen diagram works, but here you have the time axis and the different taxa are presented in relative abundance. So one of the things that caught my attention here is that we have several shifts in the vegetation. So we have here this pioneer vegetation coming in and getting out. We have the establishment of a palm swamp that was replaced at some point by another palm with different ecological conditions. And at the end, we have the establishment of this palm swamp, which is the current vegetation. But what was really interesting for me is that, again, we are in a location that receives more than 3,000 millimeters of precipitation per year. And at this particular moment, with this palm getting into the landscape and the pioneer taxa disappearing, we have a massive peak in fires. Which again, based on the nature of the place, fire occurrence is not very likely, fire occurrence of natural origin. But if that was not enough, I came back to my records and then I saw that in that particular moment, 5,000 years ago, we also found pollen grains of crops, in this case, cucurbitacea, which is a pollen grain that barely appears unless it's in cultivated places. So we're talking about almost 5,000 years ago, and there was no evidence, no archaeological evidence so far for such an ancient human occupation. Probably this was just a temporary settlement because there was a river moving and it created the right conditions for some crop cultivation nearby a lake or a pond or something similar. But it was interesting to find that if you start digging in, you can find different proxies that relate to potential human habitation. The story in the Yasuní slows down a little bit because I passed the record to my brand new PhD student based in Liverpool, and what she's going to analyze, he will tell you hopefully soon, is the relationship between these migrations that I was inferring, this appearance and disappearance of the palm swamp and these pioneer taxa. They might be related to changes in the drainage system and changes in the precipitation regime or the seasonality. So she is starting from this archaeological map where all the triangles represents archaeological sites, and there was this hypothesis that there was a large flooding event 1,300 years ago that affected massively the populations that they're living at the same time. So she is going to analyze this record. One particular thing that I find very interesting in this place is that this hypothetical, it haven't been tested yet empirically, but the hypothetical boundary between the flooded area and the not flooded area is a wonderful separation of current human culture. So it will be nice to explore what the paleo record says about. And for that, Molly, which is this person in here, she has some sequences in the flooded site, which is this part towards the west, whereas these other locations are not going to be, or supposedly are not influenced by this historical flood. So it will be nice to see how the interaction between drainage system, flooding events, human populations and vegetation evolves in Molly's thesis. If we move towards the coast, I would like to share an example from the Orinoco Delta. The Orinoco Delta is a huge swamp. It's pretty much a combination between rivers and mud. So it's the paradise of a palaeoecologist because you can go pretty much everywhere. And it's the homeland of the Warao people, which are called the people of the boat, or known in some places as the people of the boat. I haven't mentioned before that the palm swamp that I mentioned is dominated by one particular species, Mauritia flexuosa, which is this one, and it's also very abundant in the Orinoco Delta. So we have, again, a different record. I'm not going to go into detail in the record, but you can see that there are things going in and out until we've got this palm swamp, which is, again, the current vegetation. So if we just summarize the pollen diagram using a DCA, we can see that the three different zones are very clear, separated and split. And these three different zones represent a very different plant community. So at the bottom of the record, we have a coastal affinity plant community. Then this plant community is replaced by a mixed forest. And then this mixed forest is replaced by swamp forest, as I say, dominated by Mauritia flexuosa. which was kind of shocking in here is that this particular place, this bottom zone, represents a coastal affinity plant community, and our study site is located 50 kilometers away from the coast. So it was kind of hard to believe that the income of pollen grains such as the mangrove, were arriving to that place. So we started comparing with some palaeoclimatological proxies, and we saw that it was kind of the wettest interval for the last 6,000 years, when this coastal affinity or mangrove-like vegetation were populating the area. But if we go to the sea level, we can see that at that particular time is where the sea level got stabilized after the deglaciation. And then what we have seen, or what we suggested, it is because of the sea level stabilization. You can see in here our location, our study site on the current coastal area. What we infer, thanks to some works in geomorphology and some works on diffraction X-ray that we took in our core, is that actually 5,000 years ago, the coast, the shoreline was 30 kilometers inland. Because of the sea level stabilization, we have a progradation of the sediment. So it was being created more and more sediment, and the coastal area moved towards the coast as the sediment was progressing. So we have this synchronous event that because of the appearance of more sediment, the coastal vegetation was moving seaward, and we have this opportunity of the vegetation being replaced by some more continental or more non-saline water vegetation. What it is important in this part of the diagram is that we haven't talked yet about the charcoal record. If we look again to the paleoclimatological record, we can see that this is the wettest interval for the last 6,000 years, but also is the interval where we have by far the highest presence of local charcoal. These are macro charcoal particles. These are indicative of very local conditions of fire. So we have the fire activity at the same time of the wettest, again, very unlikely by natural origin. What we infer in here is that because they were coastal areas, they might have been populated by coastal cultures that migrated, abandoned the place as the coastal shoreline moved towards the sea. And that's particularly interesting because during that time, in this part of the Neotropics, there is one thing that is called the Meso-indian or the Archaic period, and they have been found evidence in Paují, in Venezuela, Trinidad, the Guayana coast, and also in Brazil, but they didn't find any archaeological evidence so far in Venezuela, probably because they were looking in the coastal area that didn't exist 5,000 years ago. So that's kind of the first indication that the human also could have been populating this Venezuelan coast in the continent. So that's called the Caribbean arc, which is mostly related to coastal sediments. But as I said, there was no evidence whatsoever in the Orinoco Delta so far. If we go towards the younger part of the sediment, we can see that there is some sort of instability climate in here produced by an enhanced variability of the ENSO. We have some charcoal record, but not as much as we had earlier on the records. So there is no clear evidence in here that humans were populating the area, or that the drivers of these fires occurrence is due to anthropogenic activities. We probably, climate is going to have an effect, and perhaps there is a mixed effect, but climate is for sure involved in this record. But if we go to the archaeological works, this particular place was, this particular moment in time was a very active in terms of migration and colonization of new territories, in terms of the islands communities, like in Trinidad. The Caribbeans also were migrating, and also we have a huge settlement in here, and probably they were migrating and they were colonizing other things. So it might be that some of the charcoal represents human presence, but as I said, we can rule out the climatic effect on these fires. Also, the development of this canyon in here, this channel river, was 3,000 years ago. And at this time, we again have this Mauritia flexuosa palm, which is widely used by pre-Columbian cultures and by the Waraos nowadays. So maybe because they have the resources, they wanted to explore, they moved, they migrated, and they colonized new zones. But again, we don't have enough evidence for supporting that statement. Finally, we have the last millennium, and again, we have an increase in the charcoal, we have the driest periods, we have the little ice age occurring here, but we also have the establishment of large groups at the mouth of the delta at that time. So, well, again, it could be a mixed signal that part of this record is due to climate and part is due to anthropogenic activities. Finally, I would like to mention an old record already, because that was for my PhD, but it was it was a very beautiful example of how palaeoecology could contribute to the debate of human occupation. The Gran Sabana is an old place, is a huge grassland that is located between the Orinoco and Amazon forests. And the savannas are kind of odd, as I said, because they are not related to humid conditions, to weather conditions. It might be related to soil conditions, but not, they do receive enough precipitation for having these forests. And actually, if you look at the landscape of the southern Gran Sabana, you can see that there are patches, small patches of forest, mostly through the rivers, but also you have these monospecific stands of Mauritia flexuosa. We have one record, and the most important thing in here is that represents the last 8,000 years. And we can see at the bottom of the record that this was not a savanna 8,000 years ago. So we have a rainforest with some patches of savanna nearby, but it was not this extensive really savanna that we can see in this picture. If we look to the other proxies, we can see that we have proxies for fire, for local moisture, and another indication. And well, to sum up, because I'm not going to get into the detail of the record, but you can see that the oldest part of the sequence is characterized by rainforest. Then we have a secondary forest, and then we have the establishment of the savanna in the last 1,500 years. Which is particularly, there's a typo in here, sorry. What it is interested in here is that the secondary dry forest, by the way, it was occurring in a dry interval. And this dry interval, the driest interval for the last 8,000 years, was showing the lowest fire records. And on the other hand, the wettest interval inferred by the local moisture proxies that we use, in this case, non-pollen pollinomorphs, this establishment of a savanna took place in the wettest moment under the highest fire evidence. And then we start thinking, if it is wet and it is fire, it might be human. So we went to the sociological studies of the current distribution of indigenous cultures in Venezuela, and this red star shows where the current site is located. And we have here two very different cultures. So we have in green the Yanomami culture, which is a forest culture, they live in the forest. And we have the Pemon culture, which is the current inhabitants of the Gran Sabana, and these are a savanna-like culture. They like open landscapes, and they use fire for many different reasons. It has an inherent, very important value within their culture, the use of fire for communication, for magic, for everything. So what we infer with all these different proxies is that up to 2.7 thousand years ago, there was some people inhabiting the forest surrounded by patches of Gran Sabana. But this culture was a forest-like culture, something like the Yanomami could be, not necessarily the Yanomami, but it's kind of shocking how close they are. Well, we just said a forest kind of community, then there was a change, probably in the climate conditions, maybe there was a change of fire and wars and fights between groups, which is also reported in archaeological works, that ended up showing a land abandonment in this particular place. And almost 1,000 years after this land abandonment, then we have the colonization of a new culture in the study sites, which are represented by a savanna-like culture, in this case, probably the Pemon, as they are inhabited nowadays. Again, this also had interesting consequences for other fields, because so far the arrival of the Pemon were only based on written documents, again by Europeans, and they were not saying the Pemon arrived at this time. They were, when we arrived, the Pemon were here. So we couldn't estimate the arrival point before this kind of jobs took place in the Gran Sabana. So for summing up, tropical South America is huge and very challenging. So the more the merrier. I always invite more people to work here and to start these collaborations, because there is plenty of space for improving the research that we do there. If you are a palynologist, there is more life beyond pollen. So the amount of information that you can get using other proxies or going outside of your field, it's amazing. Of course, palaeoecology could be a very collaborative work, so don't hesitate to contact other people, and we are happy to help if you work in other disciplines. And although we study the past, we need to look at the present to preserve a future. I really like this sort of sentence, and I will explain why. At the beginning of the talk, I was talking about the importance, the global importance of megadiverse regions and the threats that they are currently facing. So we made this, there is one thing that is called the science panel for the Amazon that I will explain a little bit later. We made this chapter about the tipping points of thresholds. So the likelihood of the Amazon forest being turned into a savanna, which has been hypothesized or by modeling studies. And we have these 5 different tipping points that if they happen separately, independently, this could happen. And we are really not far from getting to that point. For instance, the accumulated deforestation, I think that we are already in a 15% or something like that. So we are not very far from crossing this potential tipping point. If we turn the Amazon forest into a savanna, then there are going to be changes in the climate, there are going to be changes in the greenhouse emission gases, there are going to be changes in the pattern circulation of the current circulations of atmosphere and precipitation patterns. So that's something that it affects to all of us, and palaeoecology can help. We use palaeoecology in this chapter to check for potential tipping points that have been crossed in the past, or potential evidence of regeneration or resilience of these forest patches that have been impacted. So there are many things that palaeoecology can contribute to current policy-making initiatives. Last night, sorry, there are several initiatives, as I said. One is this manifest by geographers, mostly from the Latin American community and also in Spain, but anyone can sign. And this science panel for the Amazon, which is under the umbrella of the United Nations, I really recommend it. It was presented in the last COP in Glasgow in November, if I remember correctly. We are still working, we keep working. Anyone is welcome to contribute, and you have a very nice report to see the stage and future initiatives for saving or protecting the Amazon forest. That's all for me. Thanks very much for listening, and I'm happy to answer any question.